Hey there, Year 10s. I'm putting together this video to help you with the revision questions for the test this week. There's time codes in the description if you want to jump to a particular question, because I'll probably take my time answering each of these, so don't feel the pressure to sit through the whole thing if it's a topic that you're pretty comfortable with. All right, question number one, let's get started. All right, when we see that word evaluate, the clue in that word is this little guy here, that word value. So essentially you're looking for an actual number as the answer. So if I want to take my first expression and evaluate 4 bracket 3 plus 2, really just wants me to figure out what the answer is as a numeral. So I'm going to figure out what's in the bracket first. So that's 4 times 3 plus 2, which is 5. Remember just here, if we've got a number stuck to either a bracket or a variable or whatever, in algebra that just means multiply. So I want to do 4 multiplied by 5, which gives me 20. Woo, good start. Okay, for the next one, I'm gonna do 2 to the power 2, which means 2 times 2, which is 4. Now for the next one, we've got negative 3 to the power 2 as well. So this means negative 3 multiplied by negative 3. So for this one, we've got to remember that a negative times a negative gives us a positive. So 3 times 3 is 9, means I'm going to add 9 rather than, take 9 away. And what I'll do now is I'll look at this one. 12 divided by 4 is 3. So I want to take 3 away. So that leaves me with 4 plus 9, take away 3, which gives me 10. Cool. And then for the last one, there's a heap of BIMDAS related stuff going on here. We want to do 4 and then figure out within the bracket, and then in the bracket, so we want to look brackets first because we're doing BIMDAS, but within that bracket we've got a fraction, and then on top of the fraction we've got some addition to do first. So there's quite a bit going on with this one. So I'm going to do 9 divided by 3 first. And I'm doing 2 plus 7 first to give me 9. Now I'll carry on going through the bracket. Now in the bracket, 9 divided by 3 is 3. And I'm taking that 2 away from that. So now it's going to become 4 times the result of 3 take 2, which is 1. So 4 times 1, which is 4. And taking 1 away from that will give me 3 in the end. Okay, that steps it out a little bit. Okay, question number 2, we want 2 examples of a term, 2 examples of an expression, and 2 examples of an equation. Just in case you're not too sure, if I just make up an equation, this doesn't really mean anything. I'm just making something up here. Okay, so with what I've written down just here, each of these little building blocks, change the thickness of that pen if it will allow me to. Woohoo. Each of these little building blocks, they are all terms. So 3 multiplied by x squared, that's a term. 2y is a term. 25x is a term as well. When we've got at least 2 terms being added or subtracted, then that becomes an expression. And if you've got an equal sign thrown in there with a combination of terms and expressions as well, that whole thing is an equation. So yeah, so terms of those individual building blocks, I'll write you a few examples of terms. So a term could be 3x, it could be 3x squared. Regular numbers are called constant terms, that counts as well. It could be a variable with if there's no number in front, it just means one of them. So those are all examples of terms. An expression is when we add or subtract a couple of those together. So we could have 3x plus 2y. We could have 2x squared plus 23. I'm just making these up. We could have 3xy take 2z. But pretty much any combination of terms where we're adding and subtracting them. And then an equation, I hope my handwriting is legible, I'll do my best, is you've got a combination of expressions and or terms, but the dead giveaway for these is an equal sign. So say if you had 3x plus 2 equals 11, because we've got that equal sign thrown in there. That's a giveaway that it's an equation. So if we look at the next question, if we want to identify the following as a term, expression, or an equation, this is just one thing on its own. We've got a coefficient and two variables, so that's a term. The next one's got an equal sign. That's a dead giveaway that it's an equation. The next one, we've got a combination of three different terms, but there's no equal sign, so that is an expression. And the last one, we've got 2 multiplied by -4 xk, so that is another example of a term, because that's just one thing on its own. It's like one building block, if you will. Okay, question number 3. We're going to simplify the following expressions. Okay. So when we are simplifying by adding or subtracting, I'll use this first question here as an example. So 2a in algebra just means 2 multiplied by a, which really, if we think multiplicatively and go backwards from thinking multiplicatively, that just means 2 times a means we've got a plus a. Just got two lots of it. So if we think then about 6a, which is 6 multiplied by a, if we use repeated addition instead of multiplication, that would be a plus a 6 times. So this brings us to collecting like terms. So if I've got 2 multiplied by a and I add on 6 multiplied by a, means I've got a times a plus another 6 lots of a, meaning I'm going to have 8 in total. So what I've done there, I've collected what's called the like terms, but I'm only allowed to do that if the variables that we're given are identical. If it was something like 2a plus 2a plus 2a squared, 2a plus 2a, I can add those together because the variables are exactly the same. Give me 4a. But then I can't, so I can combine those two together. What I can't do is combine it with this one. I'm still going to add it on the end, but I can't smush them together into one term. So variables have to be exactly the same for us to do that. Okay, next one, 42b take away 16b. So it works the same for subtraction as well. We do 42b. If we take away 16b, we have, okay, 2 takes it, so 36 take, all right, so 26b for that one, I'm pretty sure. Yeah. Okay, for the next one, we're doing a bit of multiplying. So essentially what we have here is, if you think of it this way, you've got 3c, which means 3 times c. And then we're going to multiply that by -2 and multiply that by c to the power 2. Now, we can rearrange the order of this, no dramas, just to help us think about this. You don't have to do this as part of your working out. I'm just going to do it to explain it. But if we did 3 multiplied by -2 in isolation, that'd give us -6. And then c times c to the power 2 would give us c to the power 3. As in we've multiplied c together 3 times for that one. And then for 20d divided by 10d, you could maybe think of that as a fraction. So 10d over 10d. 20 divides, so we'll cancel off the d's first. D divided by d just cancels off. That's no, kind of like in the same way. 3 divided by 3 would give you 1. Anything divided by itself gives you 1 as well. So that's why they cancel, no dramas. And then 20 divided by 10 is 2. So that one is hopefully okay. Next question underneath. Now, we have got a few different terms being added and subtracted, but as I alluded to with this friendly guy up here, we can only combine terms together if the variables are identical. So for this question, I've got 12e and I'm taking 3e away. I can simplify those two to collect them to give me 9e. And similarly, I can do 8f take away 2f, which would be 6f. So then I'm going to add on the 6f to the end of that. Okay. And now again, e and f are 9e and 6f are not like terms because the variables are not the same. So I'm allowed to add them together, but I can't combine them. I can't smush them together into one thing. So the next one's a bit harder. So we've got 8fg, and we're taking away, now these variables, look a little different, but 8FG really just means the same as 8GF, because it's 8 times F times G is the same as 8 times G times F. So because of that, 8FG and negative 3GF are like terms. So I can say, well, 8FG take 3GF is going to be 5FG. You can write the variables in whatever order you like just there. This 2G squared F, so that G squared makes it different to the others. So I'm going to add that one on to G squared F. I'm going to add it on, but not combine it with my first one. And then I'm going to add on this 4 that I've got at the end. So similarly, 4 is not a like term to any of those. So if you've got this as your answer, that's all you need to do. Cool, next question, substituting and evaluating. So when you see that word substitute, so when it says, for example, substitute x equals 4 into the following expressions and then evaluate, you have to do 2 different things. So that word substitute just means, hey, wherever you see an x, we're going to, for this question at least, wherever you see an x, we're going to swap it for a 4. And then once you've done that, you've got to evaluate it. So you've got to figure out what the actual answer is as a numeral for this one. So I'll show you those 2 steps here. So substituting 4 for x. So instead of 3 times x, it's 3 times 4. And I'm going to add 2 onto that. 3 times 4 is 12 plus 2 is 14. Cool. Next one, negative 4 times x. So negative 4 times 4, take 1. Okay, negative 4 times 4. Well, 4 times 4 is 16, and a negative times a positive gives you a negative. So negative 16, take 1. Okay, so if I'm going to try and do this the right way around, if I'm here at 0 and now I'm 16 into the negative at negative 16, I'm going to take another one away. So it's going to get 1 more negative. So we want negative 17 for this one. I hope I got that the right way around. I think I did though. Okay, next one, x squared take away 2x. So I'm going to swap my x for a 4. So now that's 4 to the power 2. I'm going to take away from that 2 times my x value for this one, which is 4. 4 squared means 4 times 4, which is 16. Take away 2 times 4, which is 8. Should give you 8. And then the next one is probably beyond the scope of the test, but I'll show it to you anyway. So 4 multiplied by 4 to the power 0. We haven't done these sorts of indices, and I don't think you'll need to do them this week, but just for interest's sake, anything to the power 0 is 1. So it becomes 4 times 1, which is 4. So yeah, we will continue this substitution party for another 2 questions. All right, for these ones, we're going to substitute in a negative number instead. So we've got 3 multiplied by negative 3, and that's because y is equal to negative 3 for this question. So when I substitute, that's the number I've got to swap. And we're going to add 12 to that. 3 times negative 3, so 3 times 3 is 9, and negative times a positive gives you a negative. So now we've got negative 9 plus 12. I'll hope I get this the right way around. So here, we're here at negative 9. We want to add 12 onto that. So it takes us 9 to get to 0, and then another 3 where we've added on 12 in total. So negative 9 plus 12 gives us 3. Okay, next one, negative 4y. So this one's a little weird. So negative 4 multiplied by, we'll swap in y, which is negative 3, plus 1. Okay. 4 times 3 is 12, and a negative times a negative gives us a positive. So now 12 plus 1, which is 13. Woo. Ooh, the next one's pretty hard as well, but that's okay. We'll do it anyway because that's fun. So now we've got negative 3 raised to the power 3. We're going to take away from that negative 3 raised to the power 2. Okay, so negative 3 means, negative 3 to the power 3 means negative 3 times negative 3 times negative 3. All right, so negative 3 times negative 3 would be positive 9, but then 9 times negative 3 is going to give you negative 27 because it's a negative times a positive again. Whereas here we're doing negative 3 squared. So we just want this part for that. So negative 3 times negative 3. So we're going to take 9 away. Negative 27 take away negative 9 is negative 36. Cool. Next one, we've already done negative y squared in the previous question. So that's 9. Add 3 onto that gives us 12. Woohoo. Let's keep going. For the next one, we've got a bit of a combination. So we've got f is equal to 2, g is equal to 3, and h is equal to 4. So when we substitute those in, when we swap them in, we've just got to make sure we're using the right numbers. So for example here, f times g, f is 2 times g, which is 3, plus g, which is 3, times h, which is 4. So now we've got 2 times 3 is 6, plus 3 times 4, which is 12, gives us 18. Cool. Next one, 3 times f times h times g. So 3 times 2 times 3 times 4. So I'm just reading those numbers from the top here. So 3 times 2 gives us 6. 6 times, hang on, 3 times 2 is 6. 6 times 3 is 18. And 18 times 4 is 72, I'm pretty sure. It is late, bear with me. Okay, next one, we've got negative f squared. So we're going to do negative 2 to the power 2 plus 2 times 3 times 4. Okay, so now we've got, that's going to be equal to negative 4 plus 2 times 3 times 4. 2 times 3 is 6 times 4 is 2 times 3 is 6, times 4 is 24. Okay, starting off at negative 4, adding 24 gives you 20. And then for the last one, again, probably beyond the scope of this test, but anything to the power 0 equals 1. Happy days. Okay, expand the following brackets. How many more topics have we got? Oh, we've got a few. We're doing all right, though. We're doing good. This is a little different. Okay, so when we expand brackets, if we had, say, for example, 3 multiplied by a times 2, when we expand, we want to remove the bracket by multiplying whatever term we've got out the front by all the terms that we've got inside the bracket. It's called the distributive law. So for this example, we'd take 3 and multiply it by a, gives us 3a, and then 3 multiplied by 2 gives us 6. Okay, which makes sense. That 3 stuck to the bracket means we've got 3 lots of the bracket. So it'd be like a plus 2 plus a plus 2 plus a plus 2. 3 lots of a is 3a, 3 lots of 2 is 6. Cool. All right, keeping that in mind, 3 times x is 3x, 3 times 2 is 6. I didn't mean that to be literally almost exactly the same, but that's fine. Next one, negative 3 times y is negative 3y. Negative 3 times 4 is negative 12. So just be careful with your positives and negatives. 5 times 3z is 15z. 5 times negative 4 is negative 20. And then negative 4 times 2p. So negative 4 times 2 is negative 8. And times that by p. And negative 4 times negative 4 is positive 16. Woo-wee. Okay, now if... where can I write this? Okay. With the expression that we just did, so 3 bracket a plus 2 equals 3a plus 6. Going this way is expanding when we remove the bracket. Going backwards the other way is factorising. So when we're asked to factorise, we need to put the expression into brackets, essentially, by using factors. So what we want to do for this one, we think of we pretty much want the highest common factor to both of the terms. So if we think of the factors of 4, we've got 1, 2, and 4, and x as well, because it's 4x. Factors of a are 1, 2, 4, and 8. So whatever is the highest common factor, in this case 4, goes outside the bracket. And then what we put inside the bracket is essentially whatever we'd need to have on the inside, so it would multiply back out to give us 4x plus 8. So if I put an x in here, 4 multiplied by x would give me 4x if I re-expanded it, and 4 multiplied by 2 would give us 8. I've got that right, haven't I? Yeah, that's good. So if we re-expanded it, 4 times 2 gives us 8, 4 times x gives us 4x. Okay, a little bit faster for these ones. Highest common factor of 16c and 20 is going to be 4. So 4 goes on the outside of the bracket. I'd need to multiply that by 4c to get me 16c. I need to multiply by -5 to give me -20. Okay, 6c. So if we're looking at 56b take 49, highest common factor of 56b and 49 is going to be 7. 7 goes into to multiply to get 56b, we'd need to multiply by 8b. And then to get to -49, we need to multiply by -7. Then for ADH, take 60. Highest common factor for those will be 20. We need to multiply that by 4h to get to ADH, and then by -3 to get to -60. Okay, the next ones are getting to be beyond the scope of the test, but I'm gonna show you anyway. When I say beyond the scope of the test, by the way, we're not getting you to do things just to like stress you out. The idea is if you do slightly harder questions at home or in class as part of the revision, then it will make the test feel a little bit nicer when you do it for real. Anyway, so for 18ab squared and 9a squared b, 9 fits into both of those, a fits into both of those as well, and then b fits into both of them also. So then to multiply to get to 18ab squared, we need to do 9 times 2, which is 18. We've already got a times a there, so now we just need another b to get us up to b squared. And then for 9a squared b, we've already got a 9, we've already got a b, we just need another a to make it a squared if we multiplied that back out. Wonderful. But again, like I say, that's hard. And that's more to help you prepare by doing things that are a little bit trickier. Similarly, for 20 pm to the power 3 and -36 pm squared, highest common factor for these ones is going to be 4 pm squared. That'll fit into both of them. Well, yeah, they are tricky, but that's all right. We'd need to multiply that by 5m to get to 20 pm to the power 3, and we need to multiply 4 by -9 to get to -36 pm squared. Cool. Next one gets easier again. We've got -6a take 9, so -3 fits into both of those ones. We need to multiply that by 2a to get -6a, and we need to multiply that by 3 to get to 9. And then for this last one, 9 is the highest common factor for those ones. Both negative, so I'll chuck that on the outside. -9 times 4l will get us to -36l, and then times it now by -9 by 1 will get us to -9. Okay, we're getting towards the end there. Well done for sticking with me, if you know. Okay, for these ones where we expand and simplify, we want to start off by expanding them. So I'll go 4a plus 8, take 3 times 2, which is 6, take 3 times a, which is -3a. All right, 4a take 3a is a, and 8 take 6 is 2. Done. Next one, -3 times 2x is -6x, -3 times 1 is -3, -2 times x is -2x, -2 times -10 is +20. Okay, -6x take -2x is -8x, and then -3 plus 20 is +17. Cool. So for these ones, you're pretty much combining a few different skills together. You're expanding the brackets, and we've done that before, and then you're going on to collect like terms. So it's taking 2 skills that you have and putting those together. Okay, now for the last one, we want to write an algebraic expression that represents each of the following scenarios. All right, so say for example, if I had C to represent the number of students in the class at a given time. Let's say that it doesn't really matter how many there are because we're using algebra. It's not literally how many are there, we're just going to use a variable, C, to represent how many there are. Then say if we had 5 students that came in after music or whatever, we'd then have C plus 5 students in the room. If we started off with C and then half the class left to go to volleyball, you would have C divided by 2 students left. So yeah, it's not about literally how many things there are, it's just writing an expression. So for example, this first question, if we want the sum of Kyle's age and his brother's age, sum is an adding word. So if we're adding together Kyle's and Andy's ages, it's just as simple as writing K plus A for these ones. So we're adding together these variables, but it doesn't matter how old they are, we just want an expression to represent it. How old Kyle will be in 8 years' time? Well, his current age is K, however old that is. And if we add on 8 to that, that'll give us his age in 8 years' time. Difference between the number of shirts that Mr. McPherson owns and the number of t-shirts that Mr. Barker owns. For that, we want M take away B. Who has the most shirts? I don't know. I reckon it'd be pretty close. Number of spaces in the car park if there are R rows and S spaces in each row. Okay, for that one, if you've got a certain amount of rows and a certain amount of spaces, we just need to multiply those together because for every row there's going to be however many spaces there are. So that's a multiplying thing. Change from $100 if you buy something that costs C. We give the cashier our $100. They keep whatever C represents, and then we get the rest back as change. So that's a way to represent that. Cost of buying M Mars bars if they cost $1.86 each. So we've got $1.86. We're buying however many Mars bars, and we're going to represent that with the letter M. So if every M Mars bar that we buy, we need to have another lot of $1.86. That's a multiplying question. The news agency receives P pages of leaked documents. They have 8 journalists to review the documents before the 6 o'clock news. This is a good actually example of where distractors might be thrown in. The 6 o'clock news isn't relevant to the question. It's just part of the narrative of it. So if we want an expression for the number of pages each journalist needs to review. So we've got P pages in total, and we're going to split that up between 8 journalists. So P divided by 8 is what we're looking for that one. And then part H, a new proposal for resolving a tie in soccer is to remove 1 player from each team for each minute into overtime. Cool idea. If each team starts with 11 players and there is 1 referee and 2 lines people officiating the match, how many people are on the field M minutes into overtime? Okay, there's always going to be the referee and the 2 lines people are always going to be involved till the end of the game. So we've got 3 people there. Okay, but we have 11 players, and that's going to reduce by 1 for every minute of overtime that's played. So if we put all of those things together, we've got 11 people. And for every minute that's, oh, hang on a sec, if each team starts with 11, so we've actually got double that, we've got 22. And for every minute that, hang on a sec, I'm guessing it's for each team, from each team, yeah. So for every minute that goes by, 2 players are gonna leave the pitch, so take 2 times M. And we've also got to take into account the 3 officials as well. So writing that in this way is a little bit more simple. 22 plus 3 is 25. Take away 2M, as in we start off with 25 people on the pitch, and then for every minute that goes by, 2 players are gonna leave. Okay, we have finished our maths journey. Well done for listening. Give me an email or Mr. McPherson an email if you've got any questions. Thank you.